time for the last type of calculation in this chapter. Calculating the pH during a titration. Now that means that we're going to be calculating for points other than the perfect endpoint. And we're also going to be asked, instead of calculating to molarity, to calculate to pH. A couple different signs to look for. Let's look at a sample problem. Sample problem will usually start off very simply. Calculate the pH during a titration of 0.5 liters of 0.10 molar HCl when adding, and we have 4 stopping off points that we have to accomplish. Now again, this problem is really different because it's asking you to calculate the pH, not the molarity. Pretty good sign that it's this style of problem. Let's take a look at this first point, when we're adding absolutely nothing to the solution. Can you calculate the pH of 0.10 molar HCl? I would certainly hope so. So we know that pH equals the negative log of the acid concentration. So quite literally, all I have to do is plug in that concentration of that acid and type it into my calculator. You'll find out that the pH is equal to 1. Woohoo! Point A done. Let's move on to point B. Now point B is a little bit different because now I have both acid HCl and base NaOH. So like every great problem in chemistry, let's start off with that balanced chemical equation, and I'm going to write underneath each chemical what I know about them. Now if you'll notice, this is different than before. Before, we would have had one of those molarities missing. But now I have all the information for 2 reactants. Do you know what that means? It's a limiting reactant problem! Hooray! So we're going to need to figure out what the limiting reactant is in this case. Now we're not told at all what to calculate to or how to get there. That means you get to pick. I typically will pick to calculate to my salt. Now to be clear, the HCl has a low pH, the NaOH has a high pH, and all of your products have a very neutral pH. So if this is a limiting reactant scenario, one of the 2 of my reactants will run out, but I'll have extra of the other one. That means I won't have a neutral pH, although I'll be making product. I'll have excess acid or excess base that will adjust the pH. So this is really an excess reactant problem. I know that that's not usually our favorite style of problem, but we can do it. Let's start with figuring out what that limiting reactant is. So I'm going to do 2 stoichiometry problems, one that starts from the HCl and one that starts from the NaOH, and I'm going to calculate to moles of my salt. I don't really have to go any further than that. So here are my 2 stoichiometry problems, starting from those 2 different volumes, the measurements. I'm going to convert them into moles by using their separate molarities. And now finally use a mole-to-mole ratio to go to the same endpoint so I can compare them. I chose moles of NaCl. And here are my answers. Now hopefully you know what this means. If I can only make 0.020 moles of NaCl, that implies that for point B, my NaOH is my limiting reactant. And that's very important because it means I'm not going to have any of it left over, but I will have leftover HCl. So I would anticipate that at this point, my pH would be under 7. We just need to calculate how under 7 it is. So for my future stoichiometry problem, I know that everything has to start from my NaOH. And if this is an excess reactant problem, I'm going to end up calculating to my HCl. Now it's really well and good that my HCl started off as 0.10 molar, but I've used some of it up, and it's no longer 0.10 molar. My pH has changed. I'm going to need to know its new adjusted molarity. So that's a stoichiometry problem. Let's start with the NaOH and end with HCl, so I can figure out how many moles of it I've used. So let's start off with that 0.1 liters of NaOH, convert it to moles using its molarity, and apply my mole-to-mole ratio. That leaves me with 0.020 moles used of HCl. but that's not what's left over yet. So let's figure out how many moles I was given. Luckily, I was provided with not only the molarity, but also the volume of that material. I'll plug those informations into my lovely, lovely little formula for molarity. Molarity equals moles over liters, solving for the moles. And that lets me know I had 0.050 moles of HCl given. In order to find the leftovers, I just subtract those two numbers, and I'm left with 0.030 moles. Now, after I've added these solutions together, my volumes are also different. You have to mix the solutions together to get to this final result. So my final volume is not 0.5 liters, it's not 0.1 liters, it's both of them combined. So I do want to negative log the concentration of my acid to try and get to the pH. And just to kind of remind you that that concentration of that acid is going to be the 0.03 moles of HCl divided by the total volume. That total volume is my 0.5 liters plus the 0.1 liters of NaOH I've added in, at essentially 0.6 liters. And now I can go ahead and punch that into my calculator, finding that my final pH at point B is 1.3. Let's move forward and repeat this process for step C. Hopefully you'll be able to follow along. Okay, again, start with the balanced chemical equation and list the information given for both points. I have all of the information for both of my starting materials, so it's a limiting reactant problem. I'm going to calculate to moles of salt, NaCl. Here are my two stoichiometry problems. Now, what do you notice about this one? Yeah, that's right. The moles of NaCl are exactly the same. Now, what does that mean? Do I have a limiting reactant? No, I don't, which means I also don't have any excess reactant either. My HCl and my NaOH have completely annihilated each other. There's nothing left. All I have left now is water and salt. They're neutral. So if there's no excess acid or excess base, you have a neutral pH of 7. You don't have to go any further with this calculation. Last stopping off point, point D. Let's start this problem exactly the same as all the others. You have two chemicals that are reacting. Write out the equation. List the information underneath both. The sign has been provided that this is a limiting reactant problem. You have information for everything. So do your limiting reactant problem. Calculate to moles of your salt. And here what do I notice is that I am limited in how much salt I can make, not by the NaOH like before, but by the HCl. I'm only going to make 0.050 moles of NaCl. That means in this example, the HCl is the limiting reactant. Okay, well what that means is that my problem here will start with my HCl and end with my NaOH. So let's wipe the slate clean and let's do this calculation. Let's figure out how many moles of NaOH I've used. So single stoichiometry problems start with that limiting reactant, the 0.500 liters of HCl, convert it into moles, and then convert from moles of limiting reactant, HCl, to moles of excess reactant, NaOH. You'll find out that you use 0.05 moles of NaOH. Well, it's nice to know how much you've used, but you need to know how much is left, which means you need to know how much you started with. You are provided with all of the information you need right in the beginning of the problem. You have 0.5 liters and 0.2 molar NaOH. Plug and chug that into the molarity equation so you can figure out how many moles of material you are provided with. I calculated for this problem 0.100 moles of, and that should say NaOH. I'm sorry, I forgot to change that. Time to subtract from what we were given. We were given 0.100 moles. We used up 0.05 moles. That means we have 0.05 moles of NaOH left over at the end. Time to pH. Unfortunately, this time we're dealing with a base. So the equation POH equals the negative log of the base concentration is more appropriate. Now this is going to be a multi-step end. Just like before, that concentration means I have 0.050 moles of the stuff left over, but I need to divide it by the total volume to make it molarity. Well, the total volume is both of those volumes added together. So I have 1/2 liter of both solutions, which gives me a total of 1 liter. Now I can go ahead and solve. POH in this case is 1.3, which is all well and good, but the problem still asked me for pH. So I'm going to use the equation pH plus POH equals 14, plug in the number that I have, which is 1.3 for POH, solving for pH, which I find equals 12.7. Try a few of these out. I know they're a long style of problem, but I think if you keep after it, you can get it. Good luck.